Thank you very much. Good afternoon, everyone. Thanks for coming. A couple of quick observations before we get started. The first one is, well done for coming to a speech on day 2 at the end of the day with a topic that's probably pretty dry. In hindsight, maybe we should have thought of a bit of a snappier title, but we're really going to lean into that and hopefully make it a very insightful and engaging presentation. The second observation is, what a great conference. Every year I come here and I feel energized and excited by the pace of innovation and the rate of change that Databricks are pumping out in their product. I reflect on problems that we were solving a couple of years ago, things like multi-cloud data sharing, fine-grained access control in your data lake. And Databricks have now solved those problems through things like Delta sharing and through Unity Catalog. And now, big problems that we've been solving for the last couple of years, things like how to extract SAP data, are also being solved by Databricks. So the pace of innovation and the changes that they are making make this a very exciting time to be in data and analytics, and hard for our clients to really keep up with some of those changes, which I think is the value of using a partner like KPMG. We have gone all in on Databricks, both internally and externally. We use the product extensively internally for our own operations, and we consult, obviously, extensively with our clients. And so the ability of us to come to you with not only the technical expertise, the experience of using Databricks, but the functional expertise, because any team that we put together combines both technical experts and functional experts. And so today, we're going to talk to you about a very common problem of a lot of our financial services, banking, capital markets, and insurance clients, which is how to manage your regulatory reporting. As I said, it's a bit of a dry topic, but it's no less important. And why is it important? Every analytics project, every data project, you need to prove the return on investment for your stakeholders and to gain the investment for undertaking the project. Databricks themselves think about this in a few different aspects of their outcomes map: revenue growth, efficiency, and protecting the firm, risk and compliance. This solution is squarely based on the risk and compliance, and the return on investment is very, very clear. Every year, major financial institutions get fined tens and hundreds of millions of dollars for getting this wrong, for not having appropriate controls around their data, and for misstating things like regulatory compliance and regulatory reporting. So showing this type of a slide to a CFO or to a chief risk officer and saying, if you get this wrong, you're opening yourself up to these extreme ramifications. That's why we're here today, and that's why this is such an important topic. So my name is Tom Haslam. I'm a partner in our Data and Analytics Center of Excellence. I've been in the analytics field for pretty much my entire career. I had an analytics startup before we really talked about machine learning, certainly before we talked about Spark, and then joined KPMG about 20 years ago. The last 15 or so have been in the US, where I've helped to set up our Data and Analytics Center of Excellence. I'm joined by my colleague, JG.
Thanks, Tom. Hi, everybody. I'm JG Prince. I'm in the same group as Tom. We call it Lighthouse, and effectively what we do is help clients use data and analytics to solve business problems. So in my particular case, I tend to focus a lot in financial services, asset management clients, and really helping them use all the data modernization tools to improve outcomes. I come from industry, so I've actually been in consulting for about 5 years, and before I used to be in asset management, developing different data science algorithms and projects. Very happy to be here.
Thank you. So, as I said, we're going to try to keep this pretty light and move pretty quickly. The first couple of sections will talk about regulatory reporting. What is it, and how we set up data supply chains for our clients so that they can efficiently and accurately produce the numbers for their balance sheet and the regulatory reports that their regulators require. We'll then pause and have a quick demonstration to show you one of our solutions. And then we'll get into the data quality problem, because there's one thing setting up the data supply chain and getting the numbers out and doing the modeling properly, but it's another complexity to make sure that the data that goes into those models is accurate and of high quality. Again, we'll show you another demonstration of that, and then we'll wrap up with some takeaways and a call to action for you to think about when to apply some of these techniques in your day-to-day business. So the first section is around regulatory reporting and the data supply chain. And so just to set the stage, all financial services institutions, banks, capital markets, insurers, are regulated companies. They have regulators, federal and state bodies that mandate certain restrictions, how much they're allowed to lend, the strength of their balance sheet, and the way they manage this is that they require banks to be able, and insurers, to be able to report to them in specific formats of things like the strength of their balance sheet, expected credit loss, and other regulatory issues. This is a quick overview of some of the regulatory bodies. So this is a very complicated field, and there are literally scores of reports and specific compliance regulations that every financial services, capital markets, and insurance company has to comply with. The way organizations tend to do this is by setting up a data supply chain. And so this is a very simple depiction of that, where you've got all of your data sources on the left-hand side. They come into your ETL or ELT pipelines. You're checking some of them for data quality issues. You're putting them into a data store, and then you're running a bunch of models so that you can push out the reports that are required by the regulators. There's a lot of different people that have to play in this space. Your data office, your data operations, your IT support who are setting up the data pipelines, and then your compliance officers and risk officers who are checking the numbers that are being presented. And there's a lot of external people looking at this. Your regulators, your internal and external auditors, but also your investors and shareholders who want to make sure that the numbers that you're putting out are accurate and that you're complying with your regulatory requirements. So, a simple data supply chain, right? Unfortunately, the reality is that it is a rather complex task to undertake. If you can think of all the different data sources that are needed to go into these types of regulatory reports, it encompasses many different systems. Customer systems, deposit systems, loan systems, shareholder systems, investment systems. And then you've got to take all that data and model a bunch of very complicated and different numbers. This is an example of the type of complexity that we typically see in organizations. And then the last step is taking those numbers and pushing them out into the regulatory reports and the consolidated numbers that are required. So it is a very complex question, and what we typically see is that organizations have built this in a hodgepodge of ways, many different systems. Some of them are quite antiquated, and not just the source systems that are antiquated, but actually how they're doing their modeling and how they're controlling all of that data and checking it for data quality. So the answer to this problem, and I think most of us, that's why we're here at conferences like this, we recognize that this is the right way to start to transform any data supply chain, and particularly one as complex as a regulatory reporting supply chain. So if you think about this from a left to right and moving up the regulatory data supply chain maturity curve, a lot of banks are very constrained by their data ecosystem, by old systems. There are too many end-user computing examples, spreadsheets, different systems. It's very hard to manage the data aggregation. It's a very complex and expensive environment to maintain. There are proprietary restrictions where your data is locked in to specific systems, and they're also cloud-specific, and it's hard to share data in the manner that it needs. And the answer to this is obviously to start to implement a data intelligence platform like Databricks. And this opens up a range of new opportunities for you, both from the very mundane, saving money on your data operations costs, to the much more advanced, where you're able to do advanced modeling, much more predictive analytics, you're able to be efficient in how you do it, you're able to track the source of the data all the way through to the end numbers, You're able to get everybody on the organization working off the same data sets and off the right data. You're able to calculate numbers once rather than having many different groups across the organization calculate very similar numbers in different ways, and often coming up with different answers, which only creates confusion, and it certainly creates mistrust with your regulator, and will lead to some of the fines and outcomes that we showcased at the start of the presentation. So this environment is changing rapidly over the years. Pre-COVID days, it was a little bit simpler. There were fewer source systems and there were fewer regulators. But even so, what tended to happen is we had the bowl of spaghetti type data supply chain that you can see depicted in the top, the diagram at the top there. That's actually a real diagram that I've experienced from a client, and you can see the complexity of that system. Almost impossible, in fact it was impossible, for them to manage the data inputs and outputs into their regulatory reports. So when we come into clients to help them with this problem, we're all about implementing the Databricks Data Intelligence Platform, bringing what we call our enabling solutions, ambient data management, and approach for managing data quality, which we'll cover in the second half of this presentation, and our regulatory accelerators. So we have pre-built a range of models that calculate specific metrics that are required for these regulatory reports, and then push them out into the standard formats that are required by regulators. This is obviously a huge benefit and accelerator for our clients who are trying to rebuild their regulatory reporting environment. There is always a degree of customization every time you do this, but the degree of acceleration that you can get by using an organization like ours that has done this many times before for different organizations and can come with the starter code, the starter setup, is a massive accelerator. What we will typically do is output those reports and those numbers into particular regulatory reporting systems. Axiom is the most commonly used one across the financial services industry. Workiva is another one that is increasingly common, and you're also able to push that out to visualization tools like Tableau and Power BI, but increasingly we would prefer and suggest that you use, obviously, AI BI Genie as a way of investigating the provenance and the numbers underneath those regulatory reports. So to move to a very quick case study, this is a solution called a CECL model. CECL stands for Current Expected Credit Loss. Essentially, it's one number on a balance sheet that banks and financial services companies have to produce. They have to model what is my expected credit loss moving forward based on the creditors that I have and the loans that I've given out. Typically, they will model this in three different times: a standard scenario, a good economic environment, and a bad economic environment. They need to calculate a number of different metrics in order to find out their current expected credit loss. They need to understand the probability of default. What's the likelihood of a loan going bad? They need to calculate the loss if the loan goes bad at a particular point in time. They need to calculate their exposure. How much are they exposed, particularly if they've syndicated this loan out and securitized it. They need to calculate the effective interest rate. What is the likely interest rate? And they need to discount future losses in order to calculate their CECL number, their current expected credit loss number, in their balance sheet. The production of that number itself is typically a fairly complicated process, but what's even more complicated are the questions that the modeling team will typically get asked by the board, by their investors, and by their shareholders to make sure that they've done the right level of checking and can stand behind the accuracy of their CECL number. The benefits that we've noticed from clients implementing this type of a model in Databricks are various. Number one, managing data from multiple sources obviously becomes much easier because you're able to ingest the data into your data platform. Data governance and control through the use of Unity Catalog and Delta Live tables is much more accurate and much easier to manage and to understand the provenance of that data. You're able to manage your modeling risk and do much more accurate modeling using a system like Databricks. Your reporting frequency becomes much easier. It can often take a very long time to run a new CECL model each year, whereas with Databricks, it can be much faster, not just in terms of execution time, but adjusting variables through your modeling process. And you're also able to respond more quickly to changing regulations as your regulators change their requirements. I'm going to now pause and pass to JG, who will give you a quick demonstration of a CECL model in a Databricks platform.
Awesome. Thanks, Tom. Yeah, so we're going to demonstrate in practice how this looks like using the Databricks environment. Before I start the demo, just want to hit on the 4 key components of the demo. Number one, we're going to be using the medallion architecture, where we're really able to track between the bronze, silver, and gold layer the different transformation that leads to the number that effectively the bank is going to show to the regulators. Second, obviously, all of that is getting tracked through Unity Catalog. Unity Catalog is a key component of this solution. Any model we do has to go through ML flow. Obviously, everything is version control, so we can have full traceability. And then finally, no AI conference would be complete without talking about large language model, and we just do a quick demo of how you can really talk to your regulatory data using AI BI Genie. So let's get the demo started. Okay. All right, so here we are in our Databricks environment, and the first thing we can take a look at is the different layers of data we have. So here on the left, we have, again, typical medallion architecture, and the first thing we can do is take a look at our bronze layer, right, the rawest data we're working with, and we're able to go through the different tables that we're using. On the right, you have a screenshot of a snapshot of our data, description of all the fields, and description of the data in the bronze table. But what's really, again, powerful in the context of what we're trying to do here is the ability to trace any ETL, any transformation we're doing of the data. And obviously, not only for debugging, but again, being able to sort of justify any kind of number that will eventually aggregate in the silver and the gold layer. So we can keep going through all different layers, and effectively the gold layer is what the regulators are going to see, right? So we start with raw data, transform it, and then gold is really what we're going to show to regulators. And similarly, if you look at the gold layer, you're able to trace back any transformation, any ETL you have done through the entire process. Okay. Okay, now let's look a bit at how the modeling looks like in the end. So here we're taking one example, which is a charge-off rate, which is effectively the percentage of a loan that becomes lost during a default event. And that's effectively the variable we're going to report to the regulator. So it's in blue. And what's interesting to look at is compare that with different macroeconomic variables, things like the US unemployment rate that you can see here in red. And obviously, intuitively, unemployment goes up, defaults tend to go higher. We can look at it versus house price, typical inverted relationship. And here, just for summary, we can look at a correlation matrix of all the different macroeconomic variables and compare them to the results of our model. Okay, so far we're still in the whole of data science space, so typically a data scientist or a data engineer will be looking at this. The final thing we're going to look at is how good are our predictions. So we're comparing in that curve our prediction and then the actual charge-off rate that happened on a monthly basis over the past 10, 20 years. And we can see we have pretty good correlation, pretty good predictability. So as I say, this was all about the way a data scientist or an AI engineers will look at this. But how about the business users? with the LLM now, we really have a revolution, whereas really the typical user of these analytics is going to be obviously data scientists, but also the business users. And now they have the ability to phrase questions and really get very precise answers from all the data we have put into that medallion architecture. So we're able to ask questions and really get answers that are going to be very similar to what the data scientists were looking at. So here, for example, I'm saying, show me the charge-off rate that I predicted versus the actual charge-off rate. And how about us now to have an additional metric? What's the percentage accuracy? It's going to look into our data, and it's going to give me the output that I can now, as a business user, copy-paste into Excel that I'm much more comfortable with. And if I don't have time to paste into Excel, well, I can also plot things on the fly using the same interface. And this is all about that, again, that self-service analytic revolution that's really enabled by now having those large language models on top of Unity Catalog and the Delta Lake.
Thank you, JG. And this is one of the things I talked about before, the pace of innovation. One of the most, I think, interesting innovations that I've heard that Databricks are about to release is Databricks 1. So that much simpler interface for a business user to be able to access something like this. I think that's a game changer because certainly AI BI Genie and allowing people to interact with their data is great. But the ability to present that through a very simple interface like Databricks 1, I think will further revolutionize how banks and organizations are communicating questions about these models to the people who are asking, like the internal and external auditors, and particularly to the regulators, to be able to say to a regulator, yes, this number is accurate, here are the calculations that we've done, this is how we are sure that the data is coming from the right tables, is a significant step forward in terms of how quickly and easily you're able to respond to questions like that. So that's a quick example of a regulatory model and a regulatory report. What we will now move to is, okay, you've got your regulatory report, that's great. How do you know that the data that is going into that regulatory report or that model is accurate? And so now we come to the age-old problem of managing data quality. Just as before, we had the regulatory reporting data supply chain. You can think about data quality in terms of a supply chain as well, where the data should flow through your ETL pipelines. There should be a series of checks that are done, and erroneous data is singled out for resolution back in the source system, and it starts flowing again through the data supply chain. There are several different players that are involved in this type of a process as well. Your IT production support, which are managing the pipelines, your data office and your data operations, and also the business users, your data stewards, who know the data as well as anyone and should take responsibility for some of that data quality. In reality, as I think most of us know, data quality is a very retroactive, backwards-looking process, and it's done based on a series of human-generated rules in general. And there is an opportunity now to completely transform how we do data quality, in that we are now using AI and machine learning to make sure that the data is of high quality. We call this AI for data. Too often we are focused, I think, on the use of data for AI. And that's great to focus on that and having data ready to drive revenue growth, ready to do new analyses, etc. But that AI is only as good as the data that goes into it. And in the past, we've always used human-generated rules to check data quality. And we haven't thought of, hey, hang on, why aren't we using AI in order to manage our data quality? And so this is a fundamental change in how we propose and how we recommend our clients start thinking about data quality, is to start using AI to manage your data quality. And so we call that using AI for data, which then creates the right data so that you can use that data for AI. The management of this process with clients is as much a people and process issue as it is a technology issue. And this is a very simple slide, but it's one that really, really resonates with our clients because it shows the different flow of people and process that is required to really start using AI for data and using AI for data quality. So you can imagine the input data flows through your data supply chain. It goes into your data quality engine, and again, we'll use Databricks for this example. There are certainly tools that help with this as well. Excel data, Monte Carlo are some of the tools on the market. But Databricks itself has fantastic tools that are available, and we have both implemented products like Monte Carlo and Excel data, but we also say to clients, you can also do a lot of this inside Databricks itself, and that's the demonstration that we'll show today. So the data flows into your data quality engine. It's a combination of both traditional human-generated rules as well as a machine learning engine that looks at patterns in the data. In this way, you're not just limited to particular critical data elements where you've specified rules, but you can actually look across the entire data set and start to understand data quality, not just in your critical data elements, but in all rows of the data. The data will then flow through the data quality engine, and anomalous data will be put into a zone where you can start to understand what to do about it. And down the right-hand side, you can see the different personas that are involved in running this type of a data quality operation. You've got your data management office at the top. They oversee your data quality rules, and they are able to then use this system which proactively suggests different rules to them that they are then able to code into the rules. Previously, all they could do is go to the data steward and say, so tell me about your data. What are the critical data elements and what are the rules that I need to catch? It was a very, again, retrospective, limiting way of doing data quality. Now they're able to work collaboratively with the data steward and say, come to the data user and say, I've looked at your data and I've found these things that look like anomalies. Are they anomalies? And so it's a much quicker feedback process, and you're able to then code them into your rules. You're also able to work with your data operations folks to quickly catch problems as they go through the data supply chain and automate the process of pushing out tickets to say, hey, we've noticed a problem in the data, please go and fix it back in the source system, rerun the pipeline, and you don't have as much anomalous data in your production systems. And IT are also involved in this process, and they're also able to better manage the data supply chain, understand not just mechanical problems, supply chain didn't run, or the data volume was much lower than we expected, but they're also able to understand the improvement in data quality over time, and everybody is looking at that monitoring dashboard so that you can understand and continuously improve the quality of your data. This is a more realistic view of a data quality flow. You can see the simple process across the top. But down the bottom, if you can work through the numbers, number 1 is where we're ingesting data into the pipeline. 2 and 3 is where we're running our rules and our machine learning or AI on the data in that data quality engine. And then number 4 and 5 is where we're then outputting for 4 the tickets, the problems, so that they get solved quickly. And number 5 is where we're using a data quality monitoring tool or dashboard. We often use tools like Datadog, Tableau, or Power BI, and then increasingly we're using AI BI Genie to output these results. A quick story, a quick client example of where we've done this recently. We worked with a client, a very large global investment bank. We were able to take their SQL-generated rules, convert them into Databricks. It was a 75 times faster process to run those rules. We used machine learning anomaly detection techniques, and this was actually one of the most interesting parts of this particular engagement, where we were able to go to the data stewards and say, we've looked at your data and we're worried about these issues. Are they problems? And to see their faces be very surprised and get very worried and say, well, that's not supposed to be there. It was a very validating process to be able to show to them, well, here's another series of 5 or 10 or 15 rules that we've noticed are problems in your data, and we're then able to code them back into the rules that run overnight. We're also able to run some fairly simple but effective time series models so that you can see the changes in your data over time and just give people visibility into changes that are happening in their data. And finally, we're able to open up the Databricks platform to them so that they can start to explore the relationship between individual fields in their data set so that they can start to understand what are the relationships between certain fields and themselves generate their own data quality rules. Again, I'm going to pass to JG and show you a quick demonstration of this one.
Awesome. Thanks, Tom. If you don't mind, give me the clicker.
You bet.
I probably need to stop the demo a few times. Okay, so this is going to be our second and final demo. So here, similarly, like I really want to hit like the 4 key components of this demo. So number 1, we are using DQX on Spark. So DQX, if you're not aware, that's a Databricks developed but open source GitHub repository that effectively runs DQ rules in a highly performant manner, leveraging the power of Spark. So if you Google it, you'll find the repo, and I encourage everybody to look at it. I think it's a beta project that's getting developed right now and improved on a daily basis. The second thing is, as Tom mentioned, we're going to use ML and AI, and here everything will be tracked through ML flow like the previous demo. Once we find issue, we also interface with ServiceNow. So it's going to be really important to, like, when you find 1,000 different data elements that might have data issue, being able to raise a ticket and raise it to the right people, and we leverage ServiceNow for that. And then finally, like the previous example, we'll ask a few questions using AI BI Genie to, again, empower some of the business users that might be benefiting from that AI solution. Okay, see if I can pause this. All right, so we start with our workflow. So here, really, the idea is to run these processes on a daily basis, and sometimes even intraday. We've had clients ask us, can we do this intraday? Let me see if I can pause it. Okay, excellent. So here, for example, we'll have a daily process, a daily batch that will run the series of DQX deterministic rules and the algorithm on the daily basis, and you can do that very easily using the workflow and scheduler function in Databricks. Okay, let me just pause here.
Pause it there?
Sorry about that. I was trying to pause it. Okay, so then we move to the, let's see if that works.
You might just need to tell me when to pause it. I think it's just resharing.
No, I'm going to just say pause, and you can just pause it. Okay, perfect. So this is the workflow we just went through. Okay, so the second thing is, let's pause it here. Okay, so this is the way we include the DQX library, as I mentioned. So very easy to import. And then you can re-leverage the power of Spark when you run those queries. And that's how we got those 75x improvement in performance by re-leveraging the power of Spark for running DQ rules. The second thing we can do here is have a very clear definition of how the rules we're going to run. So the way we do that is using a YAML file. So I guess we can continue here. And here we're just going to flash quickly like the way we define those DQ rules. Again, everything is tracked. Everything is defined in the YAML file. So it's very clear what DQ rules we are running. OK, the second component is using machine learning model. If you don't mind pausing here for a second. We obviously have everything running through MLflow, and here what we're going to do is we're going to run effectively unsupervised and supervised machine learning algorithms. So what it means is that either the bank has had data issues before, and we can use that to have supervised learning and flag the same data issue in the future as they had in the past. But something that our client really was this idea of, we call it unknown unknowns. So running a completely unsupervised algorithm that's able to actually find issues in the data that might not have been surfaced over the past history. And that was a really powerful feature of the solution. Okay. So that's the MLflow artifacts here. So we've loaded our model, we're running them, and then now we can generate the tickets, right? So the way we did that was just connecting to the ServiceNow API, and now rather than having an output purely in a Delta live table, we can have an output as a series of tickets in ServiceNow that can then be used by the data ops team to actually remediate those issues. Okay, the final component of the solution is the dashboarding and a more like BI component. So we have a classic BI dashboard that's going to enable everybody around the bank to see trends in data qualities. So things like, what's my current data compliance? Hopefully it's 99.9%. And if I do have issue, are there increase in my data issue? Are there decrease in my data issue? And then you should be able to slice and dice those issues by different data products, by different products according to your data, right? So credit cards, deposits, different financial products, and really being able to see not only the volume of your data grow, but hopefully the number of your data errors either stay constant or ideally decrease. And that's all empowered through that interface. Now, finally, you can obviously use AI BI Genie, and again, you can ask questions in plain English. And again, that, if you think about all the personas we had on the diagram that Tom went through, not only now you have the data team that can look at data quality in details, but we have now empowered effectively the entire users of the bank to be able to understand where they stand with regards to data.
Awesome. All right, so we're right on time, and hopefully we've been able to explain how we use Databricks for regulatory reporting, what the business problem is, and how we can accelerate that process for our clients, but then also use inbuilt Databricks components to check and manage and improve the quality of the data that is going into that modeling process. So as we think about, and for you to think about, what are the types of things that your business stakeholders are struggling with in terms of regulatory reporting, the typical triggers for our clients to need help in these areas are these four things. Number one is compliance. There's often regulators that are talking to them and asking questions that they're not able to answer. And so they will issue what is called MRAs, matters requiring attention, that they are going to need to respond to their regulator and show them how they are improving their data quality over time and how they are improving their modeling process over the time. The second one is changing regulations. There are often changes that regulators are imposing that banks will need to change their modeling process. The third one is market regulations and indeed market changes. So as we go through situations like tariffs, situations like the bond market issues that we're having at the moment, they're going to have to start to rerun their models and make them more accurate given changing macroeconomic factors. And finally, mergers and acquisition activity also impacts because as banks get bigger, they are subject to more and more regulation. And so we'll often find a bank that is growing will get over the 100 billion, 500 billion range, and they will then have to implement improvements in their data quality and their regulatory reporting process. In terms of data quality, I think all of us experience this in our day-to-day work. Data quality errors, people complaining that there are quality errors in my data, and I'm reactive to data quality problems, and I'm not able to get ahead of some of these problems. Data management effort duplication. A lot of people calculating these numbers in many different places around the organization. How can I streamline that process, use functions like a feature store to make sure that you're calculating interest rate changes in one place and using that in all of your models in the same way. Visibility into your data quality, just being able to track improvements in data quality over time. And lineage and handoffs is such a big one. Being able to track back, where did this number come from, and am I using the correct data to calculate these numbers? Finally, why use KPMG for a problem like this? Well, we are auditors, and we are ranked #1 across multiple risk advisory categories. But what people don't know is that we are also the leader in worldwide data modernization, according to IDC, and their analyst report that came out last year. So coming all the way back to the start of the presentation, that's the value of using a firm like KPMG. We can bring both the technical expertise, but also the functional expertise and the ability to model those complex regulatory reports while doing it in an advanced technical way. So thank you so much for the time. We do have time for a quick question or two if anybody would like to ask, and hopefully we've kept it moving, and even though it's late in the day on a Wednesday, you've been able to follow through the process and the data quality problems.